Thanks for joining us. I'm Yash. I'll be your co-host today. I'm a content creator here at Vertex, and we are really glad to have you all join us for the Techart Open Day. And whether you are just here to see what Techart really is about, or you're interested in pursuing your career as a technical artist, you've come to the right place. And for today's session, we are joined by someone who does know a thing or two about technical art, pipelines, different shaders, and sometimes even spooky toys that come to life. So, everyone, please say hi to William Harvey. Harvey is a senior technical artist at Meta, and he's also worked at Mob Entertainment and Traega Entertainment, and has been a major contributor to the Poppy Playtime series. So if you have ever been jump scared by a spooky, stretchy toy, you might want to thank him. So for today's session, we'll go into Harvey's journey as a technical artist, what a typical day looks like in his life, what the boot camp is all about, what can you guys expect from the boot camp, and also what the job really entails. So, and also Harvey will be giving us some really cool demos, and we'll also have time for all your questions. So let's get started. So we can start first with Harvey's career and journey. So, Harvey, can you share how you got into technical art and what drew you to this hybrid discipline?
Well, good morning. Good morning, everybody. Hope that we can all learn something today. I'm really excited to share about my background in technical art. As far as discipline goes, it's one I think that's really fulfilling. It has a lot of, I think, particularly great interest. For me, when I was studying game development and art in college, I had transitioned out of a before that, I was majoring in nuclear engineering, and I found art um, and some of the graphics programs at my university really interesting. But I also had a great passion and love for mathematics and code and all things kind of science. And tech art happened to be a really interesting blend of art and science. And that's kind of what we are. We're kind of this middle bridging point between the engineering teams and your art teams. Um, so I started pursuing that as like a mainline career. Right out of college, I ended up working at a couple of VR studios as their sole tech artists. And since then, I did hop from studio to studio until I got here at Meta. Um, Mostly in that time, I've been working as a specialist in procedural generation, uh, rendering, and giving support to environment art and effects teams primarily. Um, yeah.
That is super interesting. So I'm going to dive right in. I want you to share with us what a typical day in your life as a senior technical artist looks like.
All right. Well, my day begins usually by making coffee because I can't work without it. Um, Once that's kind of settled, um, so kind of your job as a tech artist is a couple fold, and it sets up a little bit depending on the size of your team. But generally, you're going to be in contact with the other art teams at a very integrated level. Usually, you'll be on a daily level be talking to them and stand up, seeing what issues, what problems, let's say your environment art team, for example, might be dealing with, and what tools or support you might be doing for them. Sometimes this is building them a pipeline. Sometimes this is in the pre-production phase, doing a lot of performance evaluations on their assets to build guidelines and parameters. The really cool thing is TechArt has an extremely large impact on the finished game. You have a large impact on the performance criteria. It's largely on your recommendation that they will make choices about whether or not they will pursue maybe certain graphical implementations or features because it's going to be within budget. The whole concept of like a graphics budget, performance budget is something that tech artists generally determine. They're generally setting performance constraints as far as uh, polygon counts, texture sizes, the amount of possible assets in a scene based upon performance testing and evaluation. Um, so a lot of it's working super closely interdisciplinary with your artists to ensure that they have the support that they need to get their job done, as well as provide maybe tools. Provide, for example, we'll be looking at a couple um, kind of Houdini engine oriented things, but really any kind of tools that they might use along their pipeline from DCC to engine. Other parts of your day, you might be interfacing with level designers or engineering and seeing how you can make sure that their interest in their interest as stakeholders is also viewed and understood from the art side. One of the really cool things about tech arts, because you see the problem from so many sides, and generally you see the problem far out because you're building up. Usually, your job as a team, a tech artist, is to build a pipeline, a set of tools and procedures to last you throughout like the timeline of creating everything in the game. You're kind of planning long term for multiple art teams to a certain degree. Now that's like something that those are the type of responsibilities that someone like me, who's usually like a lead or the soul tech artist, would usually take up. At the discrete level, let's say if you're in a larger tech art team and you're more of an associate, which is everyone kind of in this call would be becoming like a junior TA. In that context, your day is going to be a lot more discrete. You're going to maybe be put in front of some interesting problem, uh, be it something, let's say, a shader, a material. You have to build some set of master materials that uh, an artist might need to be within a particular performance spec. You need to build a certain set of effects or work on a certain set of Niagara modules to make some effect work well. Maybe you need to do something offline. You need to be simulating something in Houdini or some other DCC. So at the associate level, you'll be doing a similar interfacing, but you'll be like at the front lines rather, building assets and building tools and implementations for the various teams that you'll be supporting.
That is again super interesting, and it's thank you for also mentioning how it how a day would look like if you start off as a junior artist. Now you have worked at numerous places. You have worked at Mob, Traeger, now you're at Meta, and you've contributed to several titles. What were some of the biggest challenges that you have tackled?
Um, I think getting things for mobile performance is really interesting. Luckily, in the beginning of my career, the first 4 or so years, I worked on VR, like kind of exclusive content. And VR is an interesting area of development, but for a tech artist, it's useful because at the very performance constrained environment, and if you're truly trying to push that envelope of visual quality, it's a good platform for learning, a bunch of tricks to kind of keep that performance down. And that would benefit me a lot further, especially, my work on the Oculus platforms, because those are essentially mobile type of hardware. So when I was at Mob Entertainment, we actually did a lot of work for building these pipelines where let's say this game that we're building has to exist on, we know it has to exist on PC, has to exist on consoles and iOS and Android. So with that in mind, you can kind of build everything from that mindset. You can build all your effects and build all your shaders and anything else that needs to render, or your lighting approach for something that has to be transitioned into mobile later on. Um, I was really happy with, we were able to get like very high quality out of our mobile. As especially I'd say it was pretty close in pairability to the especially the look quality that we got out of PC. But we were able to keep it 60 frames plus on our mobile hardware, which is kind of our target there. So that's a big area I would say. That's very interesting. More on like the art and creation side, and not like performance and maybe more into the nerd kind of type of things. Is many of the really cool systems I worked at Traega Entertainment, we were working on a open world kind of survival type of game, and for that we had to build a lot of really interesting procedural terrain and foliage solutions to interface with our AI. We had like deer and all the animals of the jungle kingdom that you could hunt down and get resources, and they would interact with each other, but they would interact based upon data that we created on our terrain to tell them where food would be or where water sources or rivers would be, and those rivers would be generate into our landscape and generate an instance out certain cliff geometry. The really cool thing about about being a tech artist, and it's kind of wraps into these type of implementations really, is that you kind of the goal here is to kind of get beyond a normal way of thinking about creating things just as particular small little art pieces, but instead creating things that you view as just a manipulation of data. Your kind of goal is to be able to see art as just data and information that you can best manipulate in tools or pipelines for your team. In our case, we have this huge set of tools to generate these vast, interesting terrains, but also have huge amounts of data that we can use from that generation to instance foliage, to set up particles, to send initialized data to AI. Those type of challenges, those really rule building challenges, I think are really, really fascinating and interesting to me. It's a lot of type of things I'm excited to cover in the boot camp.
Again, you can correct me if I'm wrong. I take it the open world survival game you're referring to was Dawn of Defiance.
Yes.
That is very cool. I like that game. Now, just directing the attention to some of the tools you have mentioned. So you were talking about Houdini. I take it you would also be covering Unreal Engine in the course. So when it comes to evolving tools like Houdini, there's always like a new update, there's always a new change. So how do you keep up to date with, Substance Painter Designer or Houdini or Unreal Engine with so many changes constantly coming in?
Yeah, so this is one of the great things I think that's a benefit of our course. So what we kind of want you to get out of our course, beyond just, oh, you can follow a couple workshops and lectures and this and that, is we want you to kind of the big part of this is shaping you to think like a tech artist. And as a tech artist, you're always staying ahead of the research and the documentation. You're kind of always putting your nose down and you're aware of the latest papers out of SIGGRAPH, the latest research and interesting examples coming out of GDC. And there are just kind of these sources of information and feedback, places that seasoned tech artists would find on places like polycounts, places like certain Twitter feeds, that certain Slack channels where a lot of tech artists hang out together, like techartists.org, for example, or Discord servers, and kind of it's one of these things where this is the case in all disciplines. At a certain point, let's say all the environments, they're environment artists, they might be um, following a particular set of 80 level articles. They might be um, all aware of a particular set of artists. They might be all um, always in the same communities, kind of communicating with each other, and that is sometimes kind of like the insider knowledge about if I'm in an interview and I'm talking to another environment artist or another tech artist, and I'm kind of getting a sense of, oh, tell me about your background, tell me the kind of things you're into. If they're kind of in the know, if they're an environment artist that has worked for a couple of years, they'll be answering that in a way that all the answers that they will give are things that I or other artists have probably already seen, especially if you kind of live in those worlds and breathe in those worlds. So what we kind of try to do is beyond just showing you a bunch of examples and walking you through kind of um, some basics of things like procedural modeling and world building, and we have a specific focus on effects and specific focus on environment art. We also kind of encourage you to kind of think like a tech artist where to go to start researching, where to go to start forming communities and connections, and like kind of naturally you will start being really up to date and being aware of, uh, you know, the latest and greatest that technology has. From Substance Suite to Side Effects Houdini to Unreal Engine. Those are the primary areas that we kind of covered during our course as far as DCCs.
And speaking of communities, the course, obviously it's not just a course where you just teach. The course also has provides people with a community, because you'll actually be a part of the community on two separate platforms, and you can always interact with your peers and stay up to date with things like that. And um, before we move to the next section, I do want to ask, what skills do you think are absolute non-negotiables for someone who wants to break into the industry as a technical artist?
Well, I'm a big believer, as you might be able to tell, in Side Effects Houdini. I kind of got my Houdini shirt out today. So Houdini is a really interesting suite in software toolkit. We teach it for a couple reasons. One, it's highly in demand. Many studios want more people on the inside that know Houdini so that they can teach it to other people. Um, but it opens up a certain level of flexibility in your ability to develop tools and solutions for teams that you maybe just don't necessarily get. A lot of your standard DCCs that are mainly focused with poly modeling tools like Cinema 4D, Maya, Max, Blender. These are all great tools, and they do really good at maybe a generalist type of solution. But the really cool thing about Houdini is that it's extremely open. It allows you to very simply with code, either Python or its own language called Vex, build out any kind of solution for any use of information. You can build pipelines to create custom bakers, to generate terrains, volumes, topology, and you can do all this um, from Unreal Engine. That's another really great thing is Houdini kind of works with this built-in integration called Houdini Engine, which allows the create basically in Houdini. It's a procedural tool. It's one of the big differences. It's kind of like Substance Designer if you guys are familiar with that, but it's like I would say that would be like proceduralism, baby's first procedural software, where Houdini is kind of like procedural, taken up to 11. And when you kind of make anything in Houdini, you're not so much interested in, let's say, making a chair or making a rose, but instead making a system or a set of procedures or a tool, we might say, that can generate infinite variations based upon user input of, chairs or roses or whatever. And what's more is these little assets, we might call them digital assets, an HDA, a .hda file, can actually be called from Unreal Engine uh, natively. So you can have these little, basically like little blueprint actors almost, that you can use to generate geometry in Engine, or take in inputs like splines or landscapes and generate all kinds of interesting things like rivers or um, skirted cliff geometry, towers, basically whatever you want to build out in your pipeline. That's like a very unique set of things that it opens up, especially on the procedural world building side of things. And also, if let's say you're more interested in maybe something on the effects side of things, Houdini has long been kind of an effects super powerhouse. Has all kinds of powerful things in it, from fracturing to volumetric pyro simulations and fluid simulations, and we get to cover a lot of that in our section on effects too, which is really exciting.
Uh, Again, I was about to bring that up actually, that Houdini is really good when it comes to VFX as well. And since we are already talking about the course and the boot camp, like, what do you hope students take away from this boot camp?
So, kind of the way we gear these courses is around um, a series of about 14 weeks or so, where we have live instruction, and kind of the first 4 to 6 weeks of that, we're kind of just trying to get you out of the the mindset of working as a traditional artist and maybe how to solve things more from a tech artist perspective, from a maybe a data first perspective, and then we kind of transition into 8 weeks of looking at examples, especially working on pipeline type examples on the effects and on the environment side. And we kind of wrap all this up with a 4 week period where we're focusing on you crafting like a really great, interesting portfolio piece, which is our capstone project. And right now, the course I'm currently teaching of this boot camp is in that period right now, and they're uh, working away on their portfolio projects. And that's the kind of the culmination of this course is to um, kind of install the firmware as it would be of how to be a tech artist, how to make technical art work in your head, but also give you the skills and direction and mentorship to kind of build like a first class portfolio project so that you can attract attention from employers and hopefully get that associate level tech art position.
And so I've just for people who are listening in, I have not personally attended the Tech Art Bootcamp, but I have attended similar boot camps here at Vertex. And um, just honestly saying, as a student, for me personally, it genuinely has been a very good experience. I think my favorite part is that you do get time to like sit one on one with your mentor and actually ask questions, get everything resolved, and also that you get help from the community. For me, I started my 3D journey very not too long ago. I would say somewhere around 2022 is when I started my 3D journey. And honestly, I have improved so much in a short span of time, primarily because of how helpful, incredibly helpful people have been. They've been really patient. So um just and also that this will take some amount of work. I'm not going to lie. If you pay attention, if you just take the feedback and actually action the feedback that you get, it will help you a lot. It will genuinely improve your portfolio drastically. However, like I said, it's a two-way traffic. So if you get a feedback, you need to action it. That bit has to come from you. So yeah, just wanted to put that in there as an honest feedback from my personal experience. Going back to this tech art boot camp though, you mentioned, Harvey, that they will be students will be working on a capstone project. Can you give us a few examples, maybe a cheeky sneak peek on the kind of projects people are working on?
Yeah, definitely. So we make we want this part to be really fun and like open. So, basically the rules I've set up for the course is that, it kind of can be whatever you want. It's, as long as you get my approval, it can be whatever you want. We kind of provide you guys with a lot of suggestions of, because what we want is you guys to make something, but one that it reads as a tech artist portfolio shot and not like an environment artist or any other type of artist, and two, that it's like it's cool enough or has something technically burdensome enough to be something that, to write home about, something that would impress an employer, hopefully. um so, just now, I think on Monday we kind of had the final round of presentations about what they want it to be, and we got everyone locked down. And the amount of different things people are doing is kind of interesting. We have some people working on whole procedural cities, some people working on ocean simulations, like very complicated approaches like fast Fourier transform. We have some people working, actually, quite a few people wanted to work on volumetric rendering, the rendering of clouds, and full scale Raymarch volumetrics. We have some people focusing on procedural modeling, some people doing procedural house generation, some people doing things like wave function collapse to generate full dungeon and set dressed kind of hallways based upon different art styles. So kind of the full gamut from stuff on effects, stuff on environment art, procedural generation, but really it's wherever you have that interest. We'll try to provide the best help and research and direction as we can in that regard. I think
Uh,
now's a good time
yeah,
maybe to take a couple questions because we do have a couple of them piling up here.
yeah.
I'll kind of do these just in order. Um, Horning asked, will we be learning about procedural runtime tools or creating runtime tools in this course? Yeah, that's a good question. So, when we say procedural, we may have heard that word used a lot, and really, we might want to think of like two different stems or flavors of procedural, and this is a runtime procedural and offline procedural. A lot of the work that we're going to be doing here, especially the work that's oriented towards something like Houdini, is what we would kind of call offline procedural, where we're using kind of these procedural rule-based generation techniques, but really as a part of the process to build some set of static at runtime uh, assets, terrains, tools that kind of are meant to be imposed at the editor level. Um, Whereas something that is runtime would be something maybe more like Minecraft or like procedural generation every single term. Most of the content that we kind of focus on is like traditional kind of pipeline, so that's an offline context. But there are a couple students that, for example, in this capstone, are doing wave function collapse, a method for hallway generation, in a runtime context. So we give a lot of support in that way. Most of the course, though, is kind of built around like building these offline kind of pipeline fit, working tools. Let's see, Elif. Hey, that's a good name. Will we be able to receive a certificate at the end of the course that we can use in our professional careers? That's a good question for Yash.
So yeah, if you we do give out certificates. When you say use it in your professional careers, I mean, you can have it, you can present it that you've completed the course, and you can present your portfolio alongside the certificate if that's what you're asking. So your answer is yes.
Uh, I'll go through a couple of these. Will we be able to access some private archives of the creation of Halo games, or finally get a clear answer at the release of Beyond or Evil 2? I don't know. I can't say. I don't know about that exactly. With a lot of departments in game dev pipeline being replaced or heavily augmented by AI automation, how do you see the future of tech art as a field that necessarily exists within the same pipeline? That's a really good question, actually, and I'll kind of vibe on it for a little bit. Basically, the question is, how do we see uh, kind of AI affecting different art pipelines and its relationship to tech art, kind of. And we kind of don't cover AI too much. We cover at the towards the end of our course tops, which is a context in Houdini where we can do a lot of artificial intelligence related data processing, and do even like training of our own networks and things like that. But generally, I would be very positive. Um, if it's gonna put, I don't really think this is something to be like that worried about, especially for tech artists. You're always gonna be very, very close to, and rising and enterprising new technologies, and it's actually your job to kind of investigate them and see where they have practical use case for pipelines. So many convolutional neural network approaches have a lot of value and have interest, especially for art teams. And there's very novel, interesting ways that you can kind of start orienting yourself um, through those pipelines. But I really wouldn't be concerned that the state of the technology is such that robots gonna show up on Monday. I think we're pretty far away from any kind of real severe changes to the industry in that way. There are some interesting things that you can do with it, and it has some interesting niche use cases. But in most major studios, I don't think it's something that you would have like a concern about. Like where I think a lot of the angst of against AI is mainly this is just kind of reminds me of when people started doing a lot of procedural generation again back in 2014 or so. Whereas before that, people really kind of poo-pooed or pushed off those type of techniques, kind of with the rise of substance. So it's not. I don't think it's something really to be afraid of, but something that actually you as a tech artist can start to implement and use these techniques to build tools to help empower your artists. Let's see. A couple other good questions we have in here. How long is this course and how many weeks, times a week does the class meet? Good question. So I think in total the course is going to be 18 weeks, 14 weeks of instruction, and then 4 weeks of a guided, capstone uh, portfolio project. We meet, I believe we meet 3 times a week. So it's a Monday, Tuesday, and those, sorry, Monday, Wednesday rather, and those are for lectures in like our lab, and then we have another like office hours open homework lab on Friday. So it's and each one of those meeting times around 2 hours each. Okay. What skills will we learn applicable across DCC packages as well? Frostbite, E, Unreal Engine. Okay. Well, we will kind of. That's a really great question from Harsad. So kind of the goal here is to make you a little bit program agnostic. So we kind of orient you towards ways of solving problems that are kind of graphically agnostic. Certain shader techniques focus on well-known solutions, like let's say, for example, you can create Veroni noise, for example. Let's say that's a solution that you might use as manipulation of some UVs with some Veroni noise to do something. Well, you can do that in almost any DCC. Any DCC where you can create points and query their information, you can do that across things like Frostbite or Ubisoft. You're still going to be writing shaders, HLSLS or GLSLS shaders, and we spend a lot of time kind of teaching you to kind of think about the world from a data first perspective. What kind of information do we have coming into the problem, and how can we manipulate it with the techniques that we know to get something out of it? Okay, cool. Um, should we have prerequisite knowledge of Python and coding before this course, or would you recommend taking Houdini class course if it is offered? As far as prereqs, I would say um, I wouldn't worry too much about the coding prereqs. One thing I will tell you is we're not going to be diving too deep into kind of Python or kind of a pipeline TD type things. We will kind of be diving into C-based languages. So if you have background in kind of something like C or C++, that will be useful. We're mainly going to be focusing on Houdini's like its own scripting language, which is basically like C, called Vex, and also HLSLS, and in some small sections GLSLS, so like kind of shader languages. But most of that's going to be like having a background knowledge in like C syntax. Mostly the useful prerequisite would be a little bit of art knowledge, having the full understanding of like the high-low workflow and the full like rigmarole of taking an asset from a place like Maya through ZBrush and Substance and back into Unreal Engine for your render. If you kind of are really comfortable and familiar with PBR and that like kind of basic stuff, like stuff for any given art discipline, I think that would set you up in a good position to know and do better. We kind of gear the course in a way, assuming that a lot of artists that aren't fairly technical are the kind of the starting point. So I wouldn't be too worried about having to be a code genius or even having to be a Houdini genius. You can come in with no Houdini experience and like I think do well in this course. Um, okay. 3D AI generation. We don't cover that, but that's something that you can definitely cover in your capstone project, and would be helpful to facilitate that. We'll of course touch upon the role of tech artists in fields like synthetic data and ML a little bit because I'm the instructor and I kind of try to bring my experience to beer. Currently, I'm a senior tech artist at Meta, and we do a little bit of synthetic data generation for ML. And funny enough, this is one of the areas where Houdini is really, really good at this, right? Kind of, if people have never heard this expression, synthetic data, basically, machine learning models work off having a bunch of examples to train against, right? If you think about something simple like image generation, something like a Midjourney or whatever, it works off having a bunch of different images. If you might use a different model or a model that's maybe highly focused on some type of solution, you might need a certain set of really specific data. One example of this, a lot of people will use something like Unreal Engine for doing training of like self-driving agents, for example, and self-driving cars. And all the different streets, the whole variations of streets and city patterns, that might be an example of a synthetic data set that was generated with a tool like Houdini. Um, we cover a lot of world building kind of tools, mainly focused in a lot of our lectures towards like making video games, right? Like focused on environment art, but a lot of the work is 100% like interchangeable, and especially some of the stuff that we cover in tops. We kind of bring that up again because it's kind of where you do a lot of the machine learning type of stuff in Unreal. We kind of cover. So that's a really fascinating kind of emerging area of tech art where we can definitely be helpful in giving you the right orientation on that. I can't really classify tech art yet. What is the difference between the activities of a technical artist and a graphics programmer? Great question. Okay. The long answer short is a tech artist cares that what it actually looks like. Where a graphics programmer cares that it works. So like you kind of are you're kind of an artist, right? That artist part really is like format. You still need to be able to execute on creating beautiful images, right? We can bring a lot of this technical knowledge to bear, and we can, in a lot of rights, be as skilled and talented as many um, graphics programmers, but you're kind of in the spot of having the artistic interests at heart. You're working with the art director and you're working with the different leads to achieve kind of their vision for shots, for scenes, for characters. So that's it's kind of a small nuance difference, but like someone who's like primarily a graphics programmer, they're maybe not going to have particular interest of like, for example, building tools and pipelines for artists, right? Whereas a graphics programmer who that's just their only job might be mostly focused on building engine side rendering tools and not building and working on things to develop the assets. I think that there's kind of a cooler benefit to being a tech artist because if you can, you have way more control. As if you're just a graphics programmer, you might be able to write crazy, interesting shaders or really cool rendering features, but you're somewhat limited by what your artist can do for you. As a tech artist, you can facilitate the generation of their entire pipeline. So if you need something, you need some particular set of data or some particular bake or information or texture or whatever for your shaders or for your rendering to work, you can kind of build that out in their tools. It kind of gives you a more holistic, I think, approach to how, scenes and data gets kind of put together. Um, okay. So the short answer to that is like we're kind of just more focused on the art side of things. Building off Brian L. and thinking specifically at GLSL, which stands for Graphics Library Shading Language, OpenGL Library Shading Language. What are some resources you'd recommend for learning this prior to enrolling in the course? As an environment artist, I have a basic understanding of shaders, but struggle to move past that. Um, wow. It's a good question. I'd say we kind of start really small, so I don't think you'll need to have a huge amount of built-up knowledge or anything like that. I would suggest Shader Toy is a really great place to start, and there's a lot of really great Shader Toy guides online. You can kind of get some interest. This is like you might call it a social media site where people share little shaders that they write on the website, and you can edit the code live, and that's a really useful way of learning GSLS. Um, but I don't think you need to get too deep. Or we start pretty low. We kind of assume we assume the assumption of like a no code assumption. We assume that the most that you've played around with is like nodes and something like Material or Niagara, and where we want to build from there a respect and understanding of the underlying arithmetic and mathematics that's going involved and like how that translates into more like code. And so we kind of build you up from a point of expecting you to come in fairly intermediate maybe in your technical abilities as an artist. Um, since you mentioned convolutional neural networks, do you think knowledge and machine learning, deep learning can be valuable as a tech artist? Can you give an example of their use in your career? Yes, I can actually. So I can give two examples, one of my own and one from other tech artists. Um, I'll give a so here's a good example I've seen from other teams. I'll tell examples that we did. So on other teams, for example, I've heard Ryan Smith is a really great example of this. He's a one of the principal tech artists over at Gearbox. They make these series of games called Borderlands. You may have heard of them. And for those games, they have a particular graphic style, and they have been making Borderlands titles for a long time. So they have a huge library of resources, especially on the materials and texturing side, that they've kind of saved at this point. And specifically, they have for their base colors, they have a certain amount of graphic drawings and lines, graffiti kind of marks that they use that's kind of hand drawn, right? This is like kind of a comic book style, and part of this is done and the look in the game comes from uh, something like some kind of edge detection and methods like that. But part of this is also just hand drawn, hand artist done in the base color pass, in Substance Painter, for example. So since they have that huge data set of models. So some data, maybe something like a neural map that we might be able to connect that model, and also an artist drawn just like that alpha of their uh, comic marks. What Ryan built was a tool where he did style transfer. I think style transfer is a really interesting use case because it's probably the most easy to like map onto particular problems. So they have a tool over there at Gearbox where they load a model in and they bake it against their high poly, and it will automatically spit out like a starting point. Okay, this is how all your comic book marks should look on the character. That's not based upon curvature or based upon uh, geometry field. It's based upon a understanding that the network had of all these previous inputs, and that's just a starting point that the artist can ignore or kind of work on top of, kind of help speed them up. That's an example of how you might have a very narrow use case of machine learning. Another example was when we were working on Project Playtime 3, which was more of a uh, like kind of a had certain nightmare elements. It had certain that were at the time kind of I guess the term would be like kind of trippy, and we had needs for our some of our effects work, especially on our volumetrics, to be a lot more stylized. We kind of implemented a really cool paper we saw out of SIGGRAPH to do style transfers on volumes. So we would take something like a Pyro sim, which is Pyro is a type of solver, a particle solver in Houdini that lets you work with big volumes and big fireballs and things kind of like this. And we have this as a volume, and we're able to pass this into renders and render out not just its color and density, but a lot of attributes like velocity and so on, and then pass that data to a network that we can train against certain images. The really cool thing about this approach was we're able to get things out of it that you couldn't get out of a normal solver. We could give it like a Picasso painting or some kind of really weird fractal kind of imagery, and we kind of try to do really well stable um, kind of um, style transfer. When the cool thing about those methods too that we were kind of playing around with is because we kind of convert everything to 2D and then convert it back into volumes. We it's easy to blend frame to frame. A lot of times people may have seen like let's say AI video, and it's all very like kind of jittery and weird looking. Turns out if you do it all like in a VDB or voxel space, you can kind of blend it back and maybe deal with a lot of those artifacts more easily. So that's an example where we're able to get some very trippy looking, kind of infinitely fractal looking explosions or voxels that you just couldn't sim otherwise. So those are like maybe niche, but like definitely you can find small little areas here and there that this technology can give you some win that you couldn't do with traditional approaches. Okay, I think we have a couple more, but let's just go ahead with some of our questions, and we'll come back to the Q&A.
Uh, yeah, that sounds good. So we have covered a lot of stuff already. Um, so what are some of the common misconceptions that students might have about technical art when they first join?
Yeah, I think the main thing is maybe just a confusion about like what exactly a tech artist does. It's like that meme of the girls like what does a 3D artist do? But kind of within art sometimes, because sometimes you'll meet artists from different areas that maybe aren't familiar. Unless they've worked really closely with the tech art team, they don't have a fully good grasp or understanding of like where our responsibilities kind of fall. And if you're maybe more on the engineering side, you kind of maybe have the same thing. Like, what's the different? We had a question kind of earlier. What's the difference between you guys and a graphics programmer? So, um, yeah, I think that like that's one really great thing we kind of want to get you out of the course is kind of we're not just we can spend a decent amount of time, let's say the first third of the course or so, kind of just getting you into a mind of working with uh, geometry and images using kind of data as the forefront, and maybe using certain DCC and approaches you may not be familiar with, things like Substance Designer and Houdini will put some focus there. But especially once we start getting into our applied sections on effects and environment art, we kind of have all those kind of focused around going through the full pipeline as like what a tech artist would do, the types of tools or pipeline um, building that you would kind of focus on as a TA. Yeah.
And since we're talking about a lot of these techniques, the end goal here is to have a portfolio piece. Hopefully, it's a job-winning portfolio piece. Now, something that I've heard a lot, or something, an advice that's usually that I've received is when you are building a portfolio piece, have like a North Star, like have a company that in mind. Like, for example, one thing I was told was I personally wanted to aim for creative assembly, and I was told make a portfolio that's in sync with what creative assembly does as a studio, as a company. So keeping that in mind, one, does that apply to a technical art portfolio as well? And two, what makes a tech art portfolio truly stand out to a recruiter?
Yeah. Okay. So I think, really, in some ways it does, in some ways it doesn't. But really, I think in the ways that always are kind of always to your benefit as a tech artist. So, uh, if I can recognize valuable and useful tech art, even if like all the art is gray box, right? You could have some set of tools and generations that like it's just the tools itself is doing great things, right? But the is maybe not has the the prettiest inputs and as a result its outputs aren't as beautiful. Artists, tech artists can see when when someone just has a Python script used to help rigging. There's only so many ways you can butter that up and make it sexy. But those are things that that other like a lead who would be reviewing your application would see. But on the flip side of that, you're still artists, right? You're getting hired to be an artist, so it's always important if you want to stand out. You need to understand you might have a lead tech artist there who might be out there on your behalf, but you're also going to have an art director. And if you can't pass their muster, if you can't execute a scene where you demonstrate an understanding of composition, lighting, contrapposto, all these important things just to making good looking renders, then you might get passed on. So we always got to have that focus in mind, even though we get very, very deep on the data orientation and like big brain solves the problems. Uh, we really are tailoring our portfolio. We're an artist, we're technical artists, we're trying to one do things that are interesting. So we're presenting something maybe like a scene or a prop or so on, something that might be artistically interesting, has some cool looking lighting, cool looking render. But beyond what you might see in something just like a normal artist, like an environment artist, character artist, or whatever, we also want our pieces to demonstrate some cool thing, demonstrate some tool building, demonstrate some understanding of, let's say, shaders, effects. Or there's also maybe a little bit of a verb. That's maybe like a fun thing about being a tech artist in your portfolio pieces. It feels to be like you're putting a little bit of verb into your pieces because there's always something that has to be doing, like a tool or something. Usually, a portfolio piece of mine is not going to have some like no video or GIF because I need to always demonstrate. Oh, here's this cool mountain pass you like, but let me actually show you all the bells and whistles when I change all the sliders and move the curves around and do different things. Um, yeah, so that kind of thing, kind of orienting your kind of pieces around kind of being beautiful art pieces, but also broke down where they're well understood, where you can kind of show the processes of how each one of these tools was made, how it fits into an overarching set of solutions towards, like, let's say in the case I use, let's say, terrain or environment art, um like those type of breakdowns, those type if a very non-technical uh, art director can look at your piece and says, "Wow, that's beautiful," and then look at the breakdown, kind of follow the breakdown, like, "Oh wow, that's really interesting ideas." You kind of are catching on. That's the kind of the type of pieces we want to help you make, so that it makes the job of a art director and lead tech artist somewhere reviewing portfolios really easy, because they'll see your piece like, "Wow, that's really pretty," and then they'll look at it and be like, "Wow, this is." They think about things the right way. They are clearly thinking through these problems and presenting them the way other tech artists do, and that's kind of what we're trying to uh, push you guys towards, so that you can have a portfolio that really stands out.
And before we get to the good stuff, which is the demo, I want to ask you, could you walk us through a technical system or a feature that you helped build for a game?
Yeah, let me think about one for a second. Um, hmm. Okay, I guess two that I can think of off the bat that were kind of interesting was I'll kind of give two separate ones. They're kind of very different. Okay, one's more of a procedural art thing. One's more of an effects thing. So, um, when I was working at Modern Entertainment, I worked on this game there called Project Playtime, which was like this multiplayer poppy playtime game. So it's like if you ever played Death by Daylight, it's that style of gameplay where like one person plays as the monster and everybody plays as like a survivor running away and so on. It's kind of asymmetric style of horror multiplayer gameplay. And that game was a very fast development cycle. We actually made that whole game in 6 months, which was pretty impressive. Very quickly after that, we started working on some of the DLC content, like the which was a map, and this map was really cool because it was extremely VFX heavy. Uh, Mob is kind of like a double A size studio. At the time, I think there were around 80 people. So, not the largest development team in the world. And part of that burden, especially, was on the effects. And my team, which was around eight or so tech artists, kind of also handled all the effects. So, we also built all the effects for that. So, that was really fun. We had just got done building like all these art pipelines for environment art and characters and animation. Now it's like, oh, wow, now we really need to start spending on that effects budget, and it gave us a space to really push the effects further than when we had before. And we have a lot of really, we are able to get a lot of really cool. Actually, what I might do, since I'm just about to share my screen for the demo, what I might actually do is just pull up this on my ArtStation portfolio, and we kind of I kind of talk about that because I actually have it there on the ArtStation. Go ahead and share my screen now. Okay, dokie. All right, cool. So, this was kind of, I think it was called Destroy a Toy. What's the name of this map? Yeah. So, we'll just give it a second to load everything up here. So this is kind of like the central hero piece of this map. Uh, the cool part about this that I really liked about it is that it was a really timing wise of our schedule. It was such that I was working on optimizing a lot of the stuff for our mobile release at the same time we were kind of working on this um, new map. But I was able to make enough time in my schedule to actually work on hero pieces. When you become a lead, a lot of times, most of your time is focused on a managerial or kind of like feedback orientations, like helping develop your junior and mid-level artist, but you try to always cut out some time to focus on like the most important central hero type assets, right? So I actually got to create this asset here in the middle, which is a kind of this forge lava fall type of effect that we can kind of see from here. um and now I think about what I might do, because um is because I don't know if in that piece it's a good, like, because a lot of these are like close up shots on the effects. I think, let me see if I can find a wide shot of that whole level. Let me just share this. So this level was kind of interesting. It was very like kind of industrial, right? So it has a lot of these kind of industrial lighting scenes. We did baked lighting too. That was another interesting challenge here, was getting really good quality results that would work at speed. We made a lot of use of the GPU light baker, and kind of this space we kind of want to fill with moving. The idea was we want to have this filled with moving machinery, and kind of have almost like a little story told by our machinery in the background here. So there's kind of like this central lava forge, and kind of the idea, this is where this evil toy company is, I guess, making all the pieces to their factory or so on. And you kind of can see the story from the very beginning of this forge, and we kind of see a breakdown of how this effect is kind of done with, these are animating spline meshes into like a pool of sensorial deformation. And these are all generated um, as tileable pieces that come from actually a fluid simulation in Houdini. Here's like kind of a little shader that kind of does that little flipping, and maybe some of the pyro bake with embers and so on. And we kind of have this story of here we have these kind of cool lava vats that are kind of pouring this lava in these crucibles, and we can kind of see this process of the lava in the central forge then being generated here, poured into these little furnaces, coming out as these compressed little blocks, and then being rolled up into sheet metal steel. This is a what's called a vertex animation texture. So it's a vat. It's a really clever method of bringing in something like a fluid simulation, which is this is a flip fluid simulation, into engine in a very performant manner. Um, Here's like that bake just by itself. Here is actually this approach is also a vat, which is kind of interesting. But this one we're just able to do some certain deformations and then do certain texturing and emissive characteristics on this little example here. So this is kind of the ideas that we want to show some kind of maybe pseudo cartoony example of like the generation of these type of rolled up steel bundles, and we kind of have this like skeletal animation, and it's synchronized with our particles and this wrap up of our steel. And through all this, we kind of have a lot of smoke and particles and so on, and we kind of have a little breakdown here of we were really in depth and built out master materials for all of our environment and characters, but also kind of built the same kind of pipeline for on the shader front for our particles. All of our particles had the ability to have motion vectors, faked lighting from multiple directions, all kinds of really interesting stuff. And everything was kind of built to be kind of mobile oriented first. So like all these particles could shut down parts of this thing like that maybe they didn't need for mobile and be maybe just like a density or a color, whereas like if you're on ultra on PC you get to have the benefit of like faked lighting, normals, all these pretty bells and whistles that kind of help blend the smoke all together and work in our art style. um yeah, so that was a really this whole shape of problems just because it was like really art directing and working really closely with the art director and with concept artists to kind of get the effects right across an entire scene. That was really fun and interesting. Um, and kind of will be, I think, touching up just in a second here on some terrain stuff. And I'll maybe talk about another interesting kind of thing is like building a lot of these open world kind of terrain oriented kind of things that I did at Traega, I think are similarly interesting, like types of problems to solve. And those are kind of, I think, the ones that we'll kind of jump into right now with the demo. Are we ready, Yash? Or I think we might do actually just answer a
Y-
couple questions before we jump into that.
Yeah, we can just get a few audience questions and we can get to the demo.
Okay. Okay, let's take a look at where we were. Let's see. Okay. Is it necessary to have Houdini Indie, or is it possible to use a Houdini Apprentice for this course? Really great question. If you have Indie, it's definitely not going to hurt you. When you purchase the course, you're going to be included in that purchase will be a Houdini Education license. So we'll be using Houdini Education. If you're not familiar with that, it's non-commercial, but unlike Apprentice, it doesn't have any of the restrictions. So Apprentice has like which is just a free license of Houdini that comes with Houdini, and you can use that to learn. But you have some limitations as far as you can't export FBXs, you can't renders have watermarks, and it doesn't really work with Houdini Engine. That integration in like Unreal Engine and Maya and other DCCs. But Houdini Education has basically has no restrictions. It's basically like using FX, but it's also like cheaper per license. So we'll be using Houdini Education for this course. What would you recommend to a tech artist who is comfortable with the technical aspects of software but wants to get better at the art part of tech art, coming up with compelling ideas for portfolio projects? Um, that's great. So really, the answer to that, we'll just keep that one short because it's more of a like a very creative type of thing. You just have to expose yourself. That I think, like in my experience, that's the biggest thing as far as like getting a feeling. Because when we say get the feeling for art things, we really just feeling confident and comfortable making decisions of taste in regards to setting up our shot, setting up our lighting. And I think the best way to grow that that part of your skill set is just to have high exposure. Luckily, there are certain areas where you can get like really high exposure, especially there's a really big motion graphics community around Houdini because of like its algorithmic approach to creating art and designs. You can get the cool thing is if you're kind of keeping your ear low and looking at a bunch of different examples and kind of immersing yourself in that kind of stuff, you can get a lot of different like inspirations as far as where to go on look development. And really just can come down to building enough scenes and working with artists. So for an associate, especially someone who, you know, traditionally in the past, people usually were already like a mid-level artist of some discipline before transitioning in the tech art. It's kind of a recent thing in the last couple of years that we kind of are training tech artists at programs like Vertex. So for me, when I was learning to be a tech artist, we kind of already it was understood that everyone who was trying to become a tech artist kind of already had this stuff because they had learned these kind of things as a traditional 3D artist. But it really is it's the same thing. It really is like a practice kind of thing, exposure, seeing a bunch of examples, building a bunch of examples, and working with art teams. You'll kind of start to build that confidence. Okay, let's see. Um, will HLSOS be 1 or 2 weeks? It will be. I think we'll cover two weeks of that content really specifically, but it comes up like a lot of the approaches will come up throughout the course. We'll do a little bit here, a little bit there. But I think 2 weeks at the start. Sorry, I missed it, but did we go through any student project final projects? If not, will we? No, because the current capstone that we're working on, they're like 3 weeks or so from finishing, so we don't have any of their. The timing is not well to have any of their stuff to show off. Would the bootcamp tackle topics such as the ethical implications of AI, blah 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 blah? Not really. We're not going to get too deep into things like that. More, we cover AI just a kind of in passing, but it's an area of like uh, study that you definitely cover, and we can orient your capstone around. Is it necessary to have? Okay, we answered that one already. There's a software called BuildBox. It's free, but in the blah blah blah, are you going to be able to use it? I love the fact that the drag and drop game software. It's a pleasure. Um, that sounds interesting. We're as far as our DCC that we're going to be kind of building. I think we're probably going to be building everything in for our lectures in Unreal. Um, I give you pretty wide latitude as far as the capstone. You can kind of render it wherever, as long as it's kind of real time. So it can be Marmoset, it can be Unity. As long as you're building those pipelines for it. So we're going to be using Unreal Engine for most of the course in that regard. A lot of interest in Beyond Good Evil 2. Uh, okay, there's a long one from HUD. Do you know about identifying what makes a good portfolio piece? From a tier work I've seen, it's either a mix between typical problems of studio experiences, but this isn't innovative. Arrow needs proc-gen VFX shaders, which makes it hard to choose to do because it feels like a manual to the wheel. That's something out to new or entirely new cutting edge issues where the TA invents some brand new solution or filling some previously unsolved issues like a huge challenge to find the new challenge for yourself, then even harder to find the mixed solutions for yourself as the problem may have very little public research documentation. So new and exciting, but insanely hard to finish and wrap up. Being that a TA is also a bridge between teams, sometimes demonstrating those problem solutions require you to be the whole team, which adds a huge development up cost of portfolio since you get into the meat of the issue. Wow, what a great question. Okay, this is actually a really, really phenomenal question that you have typed out for us. So a little bit, this is true. So but what you'll find out is that like for a lot of associates, this is not as so. There's kind of two observations that Hug God made here. That's kind of really interesting. One, it's a little bit harder in some respects to make a portfolio for tech art because you have to, again, kind of goes back to what we said before. Our portfolios also have to be kind of a verb beyond just like, oh, that's a really cool, pretty image, right? That's a cool mountain that you made or temple. Wow, nice environment art, right? Which is there's enough hard work that's involved there. We have to be showing something kind of cool and interesting, showing some set of tools. And sometimes you'll come across like the spectrum of things where it's like, oh, I've kind of seen like this this is the 16th, procedural scattering tool you maybe have seen. And then other times you'll see portfolios from tech artists and it's like, I've reinvented my own render system and like we're generating everything in an entirely new novel way based on the most common new research. Um, Obviously you want to be the latter because that's more impressive looking, especially if the end result is pretty or does something interesting. But what you might take away is a lot of those portfolios typically are seniors. Okay, and that's like an expectation we have out of seniors is that you really should be able to but say around 6 to 10 years at this job, you should be able to start creating very, very novel implementations based upon the best research, right? But we don't have that expectation for associates and juniors. So for associates and juniors, we really are just one, we're trying to see that hey, on your pro, is it pretty? Can you do the art thing by itself? But also, are you just familiar with common techniques? So like those demonstrations, procedural generation, effect shaders, even some intermediate level implementations like wave function collapse or Gershner
Goodbye and thanks.
Gershner waves are things I think that are the type of things that you'll see as an associate. So I would say the type of things that you'll kind of be geared to getting into Techart, getting into a job there are a little bit easier, right? But also there is something that yes, there is like a little bit more of some work. But this is one thing where I'd say, kind of, you're doing a solo project here. What we kind of orient you towards, and what I always orient my students towards, or anytime I've done like a tech art mentorship, is to get friends, right? Like build a community with other artists. Just start hanging out the places where artists in the discipline that you have an interest in, maybe that's effects, maybe that's environment art, where they hang out and just help them solve problems. And a lot of times, what you'll come across, and for a lot of pieces that I build for my portfolio, I'm working with artists where they're maybe doing most of, let's say, the pretty environment art stuff, and I'm building them tools. So it kind of makes that like upfront cost of doing it all yourself a little bit lighter and easier. There's other smart ways that depending on what you're demonstrating. Let's say if you're demonstrating just a tool that creates generates assets. Maybe you don't have to generate all the assets. You can just put in your portfolio. Oh, these came from Megascans or something like that. There are kind of some ways around this, and on the margins, but generally, yes, you do have an upfront higher amount of work that's required. Okay, I think we'll take one or two more, and then we'll hop into I think an example on terrain. Um, if there's time, can we describe what a typical interview for an associate technical artist might be consist of? That might be a good idea. We might Yash, remind me of this question from Sungil about what like an interview is. I think after the demo we might wrap back to that.
Yep.
Um in order to become a junior TA, do you think having a specialization is important or should it be more generalist? I would highly recommend a specialization. And kind of we're going to orient you guys in your capstone projects towards like something somewhat specialized. Where kind of the purpose of the course is that you get to see a bunch of different like kind of types of tech art. We get to see examples that maybe would be useful for like the generation of some character armor asset, some like maybe environment, hard surface, some organic solutions, some that's maybe like pipeline oriented, some effects content, and kind of so you can get a sample of things across the all the different disciplines, so that when you come to make your portfolio piece, you can make something that an area where like it stands out, where those problems seem interesting and exciting to you to kind of build. Having a specialization is always better than being a journalist. I'm a programmer trying to learn the art side for tech art. Take this. Jin Jacob. I would say, yeah, I think you would be a perfect candidate. I don't. You're still new to 3D modeling and game assets pipeline. That's totally fine. I think you. We want to both bring in people who have some of that art background and some of the programming background. So yeah, I think you'd be a great fit for the course. There's a syllabi too. Wow, yeah. Uh, there's about a month between now and the boot camp. What would you recommend someone with an environment art background do between now and then to better prepare to hit the ground running? Um, between now and then, I would say, okay, if you already have some of that like environment art background, and you kind of just know the basics of PBR and how to put together basic scenes in something like Unreal, I'd say maybe check out Side Effects Houdini if you have never touched it before, or also like Substance Designer. Those are two. Substance Designer might you play with first because we'll kind of be covering that one first, and also uh, it I think is a more lighter introduction to proceduralism. You kind of can have proceduralism where it's hard to hurt yourself. So those would be good areas to play around with a little bit. Maybe some for something like Side Effects Houdini, not required because we'll kind of be teaching this from a beginner perspective. But if you want to get a little bit of a head start, something like the Houdini isn't scary set of tutorials from Side Effects is a really great jumping off point to kind of just get your toes into Dora a little bit. Those would probably be the best uses of your time. Yes, Intagma is a great source. Great source. Okay, let's talk a
Um,
little bit. Yasha?
Sorry for just interrupting. Just one quick question. There's someone who had asked, are we going to do this in Unreal 4 or 5?
5. We're gonna be just most current version of like 5.5, I think.
Okay, and we can get started with the demo now.
Awesome. Okie dokie. All right. So are we excited to look at or talk about terrains? So we're just gonna go through like an example of maybe some terrain type of stuff, and also maybe we'll take a look at how we can maybe build geometry or certain tools that kind of talk to or take a look at that data. Before I get too deep, I kind of want to just break down what are we looking at. Like this is a kind of a tool called Houdini. Okay, and well, first things first is that if you have Houdini in front of you and you've opened it up, say, oh, I don't know anything about this tool, we'll find out. You might it might not look like this. So I'm just gonna set mine back to how it defaultly looks, which is kind of like this. It's a little sad looking, in my opinion. It's gonna look like that actually, and kind of Houdini is procedural. Okay, so how these procedures are set down is with these little nodes. Okay, so what we actually care about is getting as much of this like network real estate as possible. Funnily enough, you're not. It's not like this is not ZBrush. You're not really going to be operating in the viewport very commonly. Now you totally can. Like there are painting and sculpting tools, and there are ways to do hand selection and do some type of manual artistry in Houdini, but a lot of times we're going to be building our procedural setups, first. So you can kind of resize everything in here to your likings, but you can also create like presets for how the layout is. I'm going to use one of mine right now called Master. My Master preset, right? And all it says is gives me like maximizes my space over here. Okay, so um, what is Houdini? So Houdini really is more than like a modeling tool or any other DCC. We kind of talked about this a little bit or alluded to this a little bit earlier. It's another way to think about it is it's kind of like an IDE, especially the programmers in the room. It's kind of like an IDE for 3D is one way to think about it. It kind of has some features that make it more than just a way to manipulate polygons, but a way to understand the state of the polygon at any given node, any given procedure level, to know things about its information and its data, and then pass that onward. And we can do this on all different types of stuff. So when I come up here, first thing you might want to understand is that there's these different contexts. So if I hop up here, we have a bunch of different. This is right now we're in the objects context, and in Houdini speak, we call this SOPs, surface operators. An op, by the way, an operator is just any node, okay? And we have a little acronym for what they do. So we have TOPS, which are for automation and task operations. We have shops, which are shader setups. We have render, ROPS, things for compositing and image generation. And we have COPS, but we're mainly going to be focused here in the object and geometry context, which is where can make polygons and where we can make all other kinds of very useful, interesting things. So in here, you might notice I have this little spreadsheet. This gets real kind of nerdy into the weeds, but like from the get go, In Houdini, we're kind of interested in the data. So if I come here, one of the really cool things about the software is it gives you really cool ways of visualizing and seeing data that you just don't really get if you're just working in like Maya or Max or other DCCs. So here I have like a sphere, basic sphere, but I can see all of its points. I can actually see the point index on the surface. And when I look in this spreadsheet, I have something here called at P, and this is its position based upon this actual index. And I can middle mouse click on my geometry, and it will tell me data about the amount of triangles and points and the attributes. And I can just add bits of data. I can do like an attribute randomize here, and this will just create a random. In this case, it's going to default to a color attribute on every point. That's going to do something kind of like that. And we kind of see this CD attribute kind of show up. And these attributes have a lot of power. These are basically bits of data. In this case, they're little vectors that are on every point. They could be on a primitive or other pieces of geometry. And we can use that data to control operations. For example, we could say, let's say we do something like make this one dimensional. So it's black and white, okay? And something we can maybe even play around with our color scale. And we could say delete. I could delete geometry based upon like what this color is. And maybe let me actually let's set this to something like a little higher frequency so this white noise looks a little nicer. Okay. So say I come here and I'll just go delete this by expression. And I'll say at cd.r is greater than like 0.1 or less than 0.1 rather. I'll do that on points. And now you see it starting to kind of put these holes in my mesh, okay? Now, we kind of did like 0.5, and that's like okay, but what's interesting is this is a procedural setup. I can change that attribute. I can change this color. In this case, it's just kind of a random distribution of noise. It's maybe not super useful. I could do something maybe like labs gradient, and this will create it can be useful to create linear gradients. So here we have, I'll set the wireframe shading off. We have like a linear gradient from top to bottom. And this is kind of working like a clip where we're clipping through this value based upon some value range. That's a very simple operation of delete, but we can also change it based upon what's happening upstream. So some of the things to learn from the get-go here is one, we have access to really phenomenally deep data, just a data structure from the get-go. We can use that data to kind of control any one of these nodes. And that can be something like a delete. It can be poly extrusions. It can be all kinds of operations on geometry. What we also have is other types of data. We also have like volumes. Volumes are a very interesting area. And we'll kind of take a look at that right now. So here's the Heightfield node. And the Heightfields are kind of cool because in Houdini, kind of anything could be a volume. For example, we could take a look at our small geometry. I'll just kind of scale this up so it's easy to see in context with this terrain. Wow, let's do it like that. Okay. And I could say BDB, which from polygons, we might try that. BDBs, by the way, are like an open source volume file format. Okay. And Houdini has a lot of BDB related nodes. So you do all kinds of operations here. Houdini also has like an intrinsic volume type, and there's all kinds of different operations we can do to blend and do noise on volumes and all kinds of fun things. But additionally to that,
I'm gonna interrupt you for a second. Sorry about that. I noticed. Is everyone able to see the screen? I'm seeing messages from folks that they
oh, you know
can't see
what?
this.
That'd be really funny if we went like 10 minutes without having the screen working.
'Cause- Okay, most folks can see it. Okay, that's good. Okay,
Okay.
uh, good. Sorry about that. Just wanted to make sure.
Yeah. Okay. If you're having a hard time seeing it or finding it, open the maximize the Zoom call, and at the very top, it's going to say my name next to like meetings and whatever, and then click on that, and you should be able to see it. All right, cool. So we kind of have this ability. Actually, I'll just kind of scale this back down so that this voxel sizes works pretty well to our benefit. But we kind of can, convert. Let's say before we do this delete, just so we get something. This is a surface volume, whereas this is more of just a fog type volume. You can kind of convert any geometry into a volume and back. The cool thing about Heightfields is that they're what we call or think of as like a two-dimensional volume, where I can middle mouse click on this guy and it will have attributes as well, but they're in the format of like these like little grid volumes, and it's like 500 by 500 by 1. So it's like this infinitely small volume. And what's cool about that is that we can do certain operations on it that we don't have to worry about topology or deformations, that we can kind of just make work for us, especially in this context. We use these for terrain. So we want to just make a little mountain example here. So I'm going to go ahead and hide my geometry spreadsheet, and we'll just kind of bring this out. The first thing that you'll kind of be working with are like noises. So we can do a Heightfield noise in this context. And we can plug this in and kind of give you an idea of what this does. Wow, it does noise. Right, so what we're kind of seeing right here is in this OpenGL viewport is kind of a material that's taking our volume and kind of masking it based upon where our height is. This stack of volumes that we're actually going to use to render like out our height field that we might pass to Unreal. And here we can kind of play around with like this noise. And what's cool about Houdini is a lot of the structures for things like noise are very unified. They have multiple different noises. They have like whirly noise, which is kind of cool. We have a type of fractal additions of this noise, kind of similar to, we have a couple methods like fractal Brownian motion, very classic methods, but we also have methods that are more based on terrain interactions. And already, we might get something that's kind of interesting. Kind of the goal here is to kind of just make interesting looking shapes. It's kind of, like you would do in Substance Design. We're kind of going to make our base shapes and kind of target our more detailed shapes, or maybe have something that's dependent upon our tools. If we have a river or like a city generation, we maybe have a part that mask out. So speaking of mask, we'll kind of, in this example, we want it to have like kind of a sci-fi, or rather a fantasy kind of landscape where like some big giant died, and like just to kind of show you the type of things that we can bring in. Here we're just going to apply some noise. This is a simple whirling noise that we've played around with the amplitude on. And then we're going to take in a geometry. This is a template head geometry that comes with Houdini. And it's just this dude. He's just vibing. And what we want to do is kind of sample him onto the Heightfield to kind of show you the level of stuff that you can do. So kind of here, we're just like using the Heightfield project, and we're kind of pasting our guy right into our Heightfield. And then we're able to project a mask here. And now this mask on this face will allow us to do operations that are independent on this section separately from the rest of the terrain. In this case, we maybe want to do a blur. We're kind of blurring those shapes and kind of helping make them blend a little nicer. We kind of do an inversion of that to kind of get a different blurring factor on the rest of the terrain. And at that point, we kind of maybe just add another more micro level of, in this case, sparse convolution noise. Any kind of value gradient noise will probably be fine. We do a distort. This is kind of like a warp node. Here we're using just a curl noise, and this gets us all pretty well before we start going into any kind of simulation pass. So at this point, we're looking pretty good. You could do other things. You could, for example, use the terrace, Heightfield terrace, which, kind of, as you might expect, it does what it sounds like. It generates terraces, right? There's all kinds of things that you kind of can do to get those base shapes what you want, right? And start, getting to a particular area. Specifically, what we want to do is get to a point where we do use this erosion. So erosion is this simulator. It's a type of context in Houdini called DOP, standing for dynamic operations. These are kind of particle operations where it takes this height field and it calculates where particles would fall, where sand would tear down, where water would tear apart, and it generates not just changes to our Heightfields, but a set of masks in data. These are things here like debris and water and so on. And these are really useful. So at this stage, we kind of hop back from here. We can kind of see there's none of that. Right here, we have kind of reset the simulation. And I'll go ahead and undo this so we can kind of, you can actually see this happen frame by frame. So I come back here and let's say I go ahead and hit play here. And you can see like this simulation start to kind of build up as we kind of go. And this is something where you have a lot of wide control over changing exactly how uh, this hydro erosion happens, or the amount of precipitation, the amount of debris that falls. You have huge latitude and control over those things. But what you really get out of here is a lot of really interesting things. So these other volumes are kind of like separate masks. So for example, we could visualize those masks. In this case, I might do uh, uh, we might just do, let's say, a Heightfield scatter, right? Which is really similar to the scatter sop, which is a kind of really useful geometry sop that I could drop it down here. That kind of does what it sounds like, and it scatters points around. So here we have a sphere as our source, and here we have the scatter sop, and we can kind of control this. And what's even kind of cool is that we can use like an attribute, like our color, to control the density. So here in this case, we'll just use CD as the name of that, and based upon our gradient, we can kind of see it will choose where to put those points or not, right? And we can use these points for a lot of things. Like one of the common things in Houdini is to do something called a copy to points, right? In this case, I'll use our pig head geometry, which is a fun little geometry, kind of test geometry we use. And I'll set this like 0.1, and we can instance, let's say, geometry on those points, right? Right. And here we have a huge amount of little pig heads. I might make this a little smaller. And they've picked up these attributes that they came from. They picked up the color, for example. Now, this is a very simple example. But what's really cool is that we could control, just like we control the color, we control all kinds of things on attributes. We could do attribute randomize and do something like p scale is the name of an attribute that changes what we call point scale. Make this one dimensional. We'll set this to like a minimum 0.5 to 1. If I set this here, we'll kind of see the scale will change. If I set this to 0.5 to 2, see that scale changes a lot more extreme. I could change other types, let's say like a quaternion we have a quaternion intrinsic attribute called orient. We also have one here that's just random color. We kind of already knew we could do that. Quaternions are 4-dimensional, so we'll kind of do something like this and maybe do -1, -1, -1, and -1. And we'll call this orient. And like now they're all kind of random directions, right? So we have a lot of control of these 7 points, and these are the type of things that we would want to generate so that we can do some instancing. We can maybe pass these points to Unreal Engine to put like plants or whatever, right? What's also cool is that we can get our data just like we use like kind of this gradient here as like a threshold value for these points, and we can kind of use that to control it, right? As I kind of move this around, we're able to control exactly where those generate. We can kind of do the same thing with our Heightfields. So I'll kind of plug this guy in. So it's kind of covering us with points. Now it needs a mask, and all these kind of have this little mask input. And we kind of used this earlier with the project. And what we can do here, I can even kind of show you this with the project. Let's say we have that project mask. We kind of plug that in here. You see that now the points are only showing up on the face of this guy. But the other cool thing is that we have this mask layer, right? Like any one of our data layers that came from our erosion pass can actually be that mask. So I'll just try maybe just the debris. And here it's kind of interesting. We can kind of maybe even get rid of those incoming terrain and just look at these points. So already this is a very interesting starting point. This is a very interesting starting point to have data points that we could use to instance, let's say, a bunch of rocks, right? We could create some procedural set of rocks and start instancing them across our terrain and help scatter detail. This is just something that comes kind of for free. But we also have other data here. We could maybe just visualize some of this other data, like we have water. This is where water would kind of pull. We could maybe use these points to begin the mesh process to kind of create certain geometries for this water. We have a lot of options open to us. This is kind of where, especially in Houdini, these type of open kind of building tools is kind of works for us. Okay, so that's like a little in, intro into like kind of Houdini and some of the terrain things. We're going to kind of transition to look at some, I think, a set of solutions that we use for texturing this and also generating meshes for Nanite. I think before we do that, we're going to take a look at a couple questions. As that we let this kind of load in the background. Okay. Okie dokie. Let's take a look at our questions.
While that's loading, did you want to cover this one? Can you describe what a typical interview of an associate technical artist might consist of?
Awesome. That's a real okay. Yes. Thank you for reminding me of that question. So, um, yeah. So like, it's gonna go back. Sorry if we frame stutter at any point where we're loading this stuff. It's gonna go back a little bit to like an answer I had earlier on specialization. So like, I've been on the hiring side many times, and what it comes down to usually is that I'm looking for someone with a certain set of skills. It's like Liam Neeson did Take It almost. Um, they're gonna need somebody, and they're looking for someone with that skills. Like I'm not getting that head count. I'm not wasting that on just like some generic person who is there's no even amounts of everything. I don't want even amounts of everything. I have a guy already that maybe is really good at Python. I don't need another guy who's good at Python. I got that. What I need is a guy who's really good at X thing. He's really good at Pyro and Houdini. He's really good at whatever. So a little bit of this is dependent, like kind of happens before you even get to the interview. Like you even getting the interview is dependent upon, let's say, you could be entirely skilled and talented, but it's like we looked at your portfolio, you're a great artist, but we just don't need those skills right now. So assuming you kind of get to that kind of interview, you kind of have usually will have multiple stages to an interview. The first stage, you kind of are talking to kind of the recruiters, and they're just kind of trying to get past like a basic set of checks. A lot of times, these recruiters maybe sometimes you have really good technical recruiters, sometimes you have recruiters who maybe are only really looking for certain keywords, and maybe it's like let's say in our JD, our job description that we looked at. I mean, that's something that I as a generally how those are made is I as a lead or someone who needs to get this done, I need people, so I make a small bullet point list, and maybe then I'll use like ChatGPT or something like that to make the spreadsheet. But those points come out there like the use of tools, what you're going to be doing, who you're going to be supporting, are kind of will tell you. And if you don't see like Houdini in the JD at all, they might find that interesting, but it's probably not going to probably because they just don't need that for that role. Maybe what they need in that role was technical animation or effect support, and they or whatever, and they might say as much. Um, assuming you get kind of past those screening points, usually you'll be in front of like your art director and your lead, and they're kind of looking for different things. Where like kind of a lead is kind of making sure that you're going to fit in well as a tech artist, that you're going to know your stuff. That if let's say they need someone who specializes, let's say in terrains, like we're kind of looking at right now, or like procedural world building, that you kind of know that pipeline. They're going to communicate with you and kind of ask you questions, and those that ask the questions should like naturally evolve into like kind of a conversation where you guys are talking the same energy, you guys are referencing the same artists and the same techniques or some familiarity there. The art director on the other hand is usually going to be kind of orienting you towards, are you going to play well, or are you going to be good with the other artists, because a lot of trust gets put into a tech artist. Tech artists are kind of there to put the fires out when everything's broken in the art department, and there needs to be someone who it's challenging. It's one of the more fun parts of the job, in my opinion, is kind of the communication aspect, because your job is really to be able to research, understand, and communicate extremely technical content. Uh, sometimes the math, let's say you're doing something like FFT, for example, the math there is like the literally the same type of math used for like quantum mechanics. It's very deep level, Fourier analysis, and you need to be able to communicate maybe that difficulty, maybe what that impact is in the timeline of creating those tools, or like the performance criteria or whatever, to usually a very non-technical crowd. Everyone's a game developer, so we're all decently technical, much more technical than my mom, for example. But um, as far as like developers go, you're going to be communicating with, like, say, some people who are extremely close to the low level data, like some of your engineers, but also like concept artists, uh, directors, project managers, and kind of the really cool thing that the that they're kind of looking for there is like how you strive in there. So like an art director is really going to ask you questions like, hey, if I come to you with a question, if I'm the art director, I have some big problem, can you communicate back to me a solution I can understand and I can pass on to all the other leads, right? So like there's kind of these two types of things they're looking for at the same time. One, there's this technical proficiency, and you should just have confidence in yourself from doing those projects to kind of communicate that. But also, this is kind of goes back to where I say it's helpful to work in like a large class kind of lecture that we have, or just build those communities with other artists and work with artists, because the more time you have working with artists, building tools that are art friendly and for artists, are you able to kind of answer those kind of soft skills? How do you work with the team? How do you orient yourself? Those are the type of solution things that like can help you with like the art director and kind of getting that job. I think that's a good like premise for like all the types of considerations you're probably going to be faced with as at an associate level interview. Okay, with that, um, let's see. I'll look for one more question, then we'll kind of dive into the rest of the demo. Uh, I think we covered a lot of the tougher ones. I think here's one last one. Thanks for hosting today's workshop Q&A. Do you have any books or recommended reading for real-time technical artists, best practices and methodologies? That's a really great question, Andy. I love books. I'm a big book believer, okay? All the knowledge is actually in books. A lot of it doesn't actually get onto the internet. A lot of times internet solutions are like recopied. Something from an actual textbook on graphics is really useful. I have a graphics library of my own that I kind of keep updated. I would suggest uh, something like real time rendering. If you're really on the more program or shader programming side of things, that's a really great read. The GPU gem titles, really great reference sources. Physically based rendering is a really well known text for like rendering and things like that. But there's a lot of, as far as like Houdini and like kind of tools based art stuff, like a lot of these books are really interesting, but they're kind of more like proof of concept. Here's like more a math side of things or things like this. As far as like just like the sad thing or the interesting thing is like software changes, like just the tools itself will change so often. Like writing a book about like the best ways to do something in Houdini might be out of date in like 5 years. But a lot of those underlying like rendering techniques and math, it's going to be the same. Even when like I have books over here like from the 80s, I have books from Manuel Mandelbrot that still hold up and I still use as reference today. So I'd say books like that I would highly recommend. Um, okay, let's go ahead and break this piece down. So kind of what we want to showcase here is kind of how we can use Houdini to generate so more pipeline type oriented things. So we kind of showed you we can generate some points and things like that. This we're going to kind of showcase that we can generate geometry as well and make that in like kind of a batched way, and maybe also some work on textures. So we'll kind of just do a speed through of this graph. I think we want to be careful of time a little bit, so I think we'll keep maybe about another 15 minutes or so for this demo, and then we'll kind of transition to our last Q&A. Okay, so we're just going to do some things here. We're going to start with kind of a grid. I want this to kind of be rotated. You can't like super easily rotate these volumes, so we can convert this into geometry just by getting the bounds here. And this is now geometry. And I can rotate this, project that back down, and now I have something to kind of start from. I want just kind of a cliff here. I do a little noise, just some actually some Shishebi noise actually. We do some distorts, And then we do a kind of a similar thing to the erosion pass where we kind of generate these flow fields. And these flow fields are kind of just an attribute. And we haven't changed the topology at this point. We just kind of painted this into the mask. And now we can use that mask to actually change the geometry. So this is a little faster sometimes than waiting on the solver to calculate every frame because we don't need to wait for it for this. So here we kind of are just using this mask shrink to kind of push geometry down. And we're kind of sharpening it. We're inverting, sharpening, and then we're going to kind of go ahead and just do some blur passes and clear that mask. And already we kind of have something that looks kind of halfway okay. Um, and this could be decent for like a cliff, but I kind of want to use this in a funny, interesting way to take this like kind of gradient that we had, like kind of this cliffy gradient, and kind of remap this gradient into different shapes or different profiles. In this case, I'm interested in kind of making a canyon, so we can use this remap node. Um, and the remap node, I'll kind of drop one down here. Is kind of cool. Um, it basically gives you the ability to remap the value range, right, of the entire thing here. So you could, one really cool way is I like to do sometimes is sometimes I'll just go straight for the shape, but other times I might think about what I'm really interested in is I'm interested in some changes, some interesting artistic uh, distribution of, let's say, certain noise or certain high frequency and low frequency data. And what I might just try to do is first generate that like in a kind of a linear gradient across some kind of height gradient that's something like kind of like this, and then just remap that to create mountain ranges or create um, valleys or whatever. The benefit here though is because I can always do another erosion pass, and I can also make my interpolation here to be like more smooth. I can use splines, for example. That kind of changes how that interpolation works as I add more or less shapes. You can kind of play around with this, and we can use this profile to get any kind of side profile kind of we're going for. I guess it's more like this. Um, in my case, the example I have here, we kind of went for kind of this type of example. And I went for this for a couple of reasons. One, I think it will work out well for our demo for things like river, which we used to generate, and also cliffs. It's kind of a smaller and compact example. We're going to go ahead and grab a mask right here of the cliffs. And we can just use this mask by feature, and we can just get the slope angle here. I'm going to use that to kind of blur things, and we'll also do a little bit of cropping of our geometry down. And now we have like kind of this remapped setup that we can now run through a road solver. So if we kind of run through that road solver, we can kind of pre-visualize that, right? It has all kinds of these layers and debris and things that you can use to kind of look at things. Okay, interesting. Um, but on the texturing side, we'll kind of look at the texture side first, and then maybe hop to the some of the geometry generation side. Here we kind of have a lot of abilities. So I decided to just go ahead and do uh, another flow field. And basically here we're just creating different masks, and we're going to use those to do different coloring processes that we can pass on. These masks that we will eventually have pass, and what we do in the course is we kind of pass these into packed textures that we can do and run different layers in our terrain material, but also we can use these as elements of a base color pass. We'll kind of hop through here for speed a little bit. Um, we have a curvature pass here. We are generating ambient occlusion across the geometry, a couple different variations of types of ambient occlusion, various masks where we get kind of different gradients of our field, and including like the bottom of it, shapes that we might consider kind of like river or the top of our geometry or the mid-level parts of our geometry. Just things that might be useful to us in a texturing context. Here we're getting kind of the tops. And kind of we get to a point here where we can kind of pack these textures into exports, or we can do kind of something like this where we're taking in our height as a gradient, and we're kind of passing a color through any one of these different masks, and we can start to build up something kind of like this that maybe it's okay looking. It could be a starting point for our base color that we may also have tiling textures on top of. But what helps out this type of thing, especially, is to have some kind of geometry we can tessellate in Engine. And we can generate this off of the same set of data. So over here, we can kind of take this Heightfield and we're going to generate a set of slopes first that we're going to use to create our geometry. And we can go ahead and just convert this geometry with this height field, and this kind of just converts it into like actual polygons, right? And I can set this to like smooth wireframe, and we can zoom in. We can't see those quads, right? And what's cool is I can use that attribute because now this mask is just like that CD attribute we saw earlier that we used to kind of cut apart and delete. We kind of do the exact same setup here where we kind of delete by CD, right? And what that does for us is pretty great. We got these separate pieces. We'll kind of walk through a little faster. So we kind of just delete some of the small pieces and we just do a pass on UVs and we do a pass on just retopologization. So because sometimes these the geometry that comes right out of that convert node is not necessarily what we want, and we maybe want to control specifically every single separate mesh piece's triangle count, right? Give this a second to actually think. Okay. So say you have right now we're looking at around 300 or so triangles. What I like, I have a bunch of references in my graph here, and we have a bunch of examples of like geological striation patterns, like these like kind of banding patterns. I kind of want that a little bit. So my way to do that was to have just a line here, okay, that I create based upon getting some data in the form of expressions about the bounding box of my terrain. So we have a kind of a point here, and we're now just going to fill that point with that line rather with a bunch of random points. We might even give a little bit of random jitterness to those points, and then we're going to give them ultimately a set of random attributes. A random attribute called class based upon what their current index is. We kind of do that down here in a wrangle. And we're just going to use this. It's going to be really similar to using like that attribute randomize. We just use this because we want a particular range of colors. So we kind of use this particular color range here. And what we can do is just transfer that color off of that line to my whole piece of geometry. Okay. So if, let's say, for example, I did like an attribute randomize and just got a random color to kind of show you what's going on here. And look here, instead, we kind of get this like random assortment of colors. And I could kind of use this as a mask or any other kind of things. Here, we kind of just want to manually author kind of, or just author a range of palettes that are going to work for us just as a base color. That's primarily how we're using this. And from there, we're kind of in a good space. We can kind of just do some processes here to do a little bit of blurring on that geometry. And we kind of come down to this part a little bit. And I'll go ahead and do this. We have an alpha here that we're kind of using to pin the sides so displacement doesn't like uh, reveal our shells. But I'm gonna turn off our alpha just so we can see our geometry. Let's do a little bit of subdivision, and then we can do displacement of this geometry using some triplanar mapping. So we have just a set of we're at like 3 million polygon high geometry count, and now we're going to do a set of displacements based upon Heightfield that we have created in Substance Designer, and we cover that during the course a little bit. And this gives us some pretty decent geometry that's already kind of good enough, really, to begin our export. And we can kind of procedurally export this stuff and kind of bring this in with our terrain. So we kind of have our terrain as well, and these kind of sit on top. And having kind of both of them work together, we can kind of generate really great looking results. We might even pull up while we're kind of going to our last section of Q&A. We'll kind of do like the, cooking show. Pull the cooked food out of the oven and open up Unreal here and show you kind of what that end result may look like. I think at this point, yeah, let's go ahead and take some more questions.
I see some coming in. So Harshad asks, what is the system spec we would need to run these sims?
Good question. I mean, truthfully, you can run pretty low. Like my machine, I kind of gear most of my classes around like more performant oriented like kind of machines because I think this machine is kind of an aging machine that happens to be in this office of mine. So I'm running like a 980 Ti. So don't be too concerned. Any like graphics generation, any graphics card and CPU, at least from that generation to now, we'll be able to run the type of stuff that we're working on.
Uh, Next one is Peter asks, do you have any thoughts or experience with PCG? Do HDAs interface well with it?
Yeah, really great question. So actually, we use PCG in our course. Actually, we actually cover a little bit of PCG like towards the end of our section on environments. And what we do is actually kind of cool. So like for example, when we kind of showcase, I'll set this to manual mode so we just go a little fast. Oh, I'm not sharing my screen anymore. Let me just while our Unreal opens up in the background. We were kind of playing around and showing you kind of like these Heightfield scatters. So this type of thing, what we can actually do here, let's say all this data, we can in Houdini PCG export, okay? And that point cloud is now a CSV file. It's going to be a data table in Unreal that we can actually, using the side effects plugin, pull into PCG. So we actually have a pipeline here where we can really quickly just take data that comes from Houdini and get it into PCG, mostly for things like instancing, but also all kinds of clever procedural content generation. It's really interesting. PCG is really interesting. It's definitely emerging. It's still a little bit in its beta phase. So I don't know if I would recommend it for very deep, complex production work at the moment, but like we show you a couple methods that we can kind of use it. Uh, HDAs can talk to them. Really, we find the best way is to do either like CSV. Alembics are also useful ways to communicate, but if you want to work it with like a HDA, you can have those HDAs like kind of generate like on demand, just like you can have an HDA like bake textures or whatever. You can generate these files. You can kind of string these things together with Python. So that's kind of the way we kind of operate with them. The really cool thing is that how um, Houdini kind of works for us is or actually like the other way around. PCG, the really cool thing, a lot of the you know what? I think we have a little bit of a slow down a little bit. Can you guys hear me?
Mhm.
All right. I was freezing up a little bit on my side. Okay. Awesome. PCG tools like PCG, and also to a little bit lesser degree, Niagara. Uh, Epic was really inspired by the work of the guys at Side Effects. So a lot of, especially the attribute orientation of how these tools works, was kind of borrowed from Side Effects to a degree. So there's a lot of really common parallels for when you're passing data through particles or passing data into these PCG, a lot of the way they think about information and exchange of data is very, very similar. So we have a lot of flexibility there. Thank you, Jin Yu. Hope to see you in the course. Could you send a Discord link to the TA Discord you mentioned near the start of the talk? I think the one I mentioned mainly was like was a more of an environment artist one. It's called a Dynasty. Okay. Let's see if the Unreal is like loaded up. This to lit. So like this is kind of put this to game is kind of like kind of our final close to like kind of what our final sample might look like. Um what I might do just to save us a little bit of time here because I don't think I've opened so well, so it's just doing some initial shader instancing stuff. I'll just hide a little bit of this foliage. But which by the way, we're also generating all this foliage and these rocks all in PCG. And we're doing a little bit of it with okay. Yeah, do we have any other questions?
Yeah, actually, there's a few more. So Igor asks, how can we know which skills might be more valuable for recruiters in order to maximize our chances to get the job? Or should we focus more on making what we like to do and hope it aligns with the job descriptions?
Well, I always think the first thing is, important regardless. Like, it's very important, I think, to be creative and to have like to find some passion, right? Because that passion is going to be most valuable towards your longevity. Really, it just comes on to like being kind of LinkedIn, right? Like, and being like seeing a lot of um being on teams that recruit, and also seeing like the JDs that people put out. Especially if you're looking for a job, you should be in a position to read a lot of job descriptions, right? Come across all these different requirements, and you maybe can notice that certain requirements are asked more than others, or in different areas, and you can kind of tailor yourself in that regard. Like, maybe you want to be super like me, kind of procedurally oriented and kind of doing the Houdini stuff. Maybe you want to work more with characters or do some technical animation. You can find JDs that are kind of aligned that way. I don't know if it's never really a thing in my mind of like, oh, you know what the industry needs right now, what's really in high demand is X of this type of person. Really, it's more just at a team level. Really, like you understand, like it's much more granular. Like, oftentimes, oh, I could just have my guy he was my effects god. He was my guy who solved all of our problems, but he just quit on us. Okay, he just like he had a midlife crisis and he's out the door. So now we need a new person. It can be like as simple as that, right? Like, you can just have some need that shows up on a team, and that's what's creating the JD. So really, I wouldn't try to guide your specialization. Like, there are some things like emerging technologies that you can be aware of, that some of this AI stuff, we have a lot of questions about that. Like, learning how you can learn about those techniques and maybe approach that from a well-intentioned and like intelligent way to create more value for the artists you work with, or approaches like proceduralism and Houdini. These are all different approaches and things that you can kind of put under your belt. But I wouldn't be too concerned. You kind of just need to have like just a generic focus, and that focus can be as big as, oh, I do environment art support, right? Or I do effect support. Like, it can be kind of broad as that, and you can kind of tailor in there. All right. Map is, I think the shaders have loaded, so I'm not like walking around. So like, this is kind of like the end product really of all this procedural generation. I think my screen is sharing, where we have our landscape, and I might even just grab all of our instancing assets. I'll kind of make them not visible. I think we also maybe have some other foliage assets. Maybe I think I have that in a map down here. I can maybe make disappear. Okay. So we have kind of our landscape, and we have kind of these geometry pieces. So we have kind of this base landscape, and this is kind of a different approach that we do. We kind of show multiple approaches to textures and some iterations. Here we have some grass sections that we've kind of painted, but we also have some of this detail and tiling textures that we kind of bring in from this terrain. But we also have all these nanite meshes, and these are all nanite generation. We can kind of go look at our nanite visualizer, and we see that we have millions of triangles and so on in the scene that are being remeshed and all that. And then we can kind of take that data and push it further and start to bring in all kinds of foliage content based upon, let's say we look at our rocks, for example. Let's see. All right, so these are all kind of based upon those different feedback, those things like debris and those different passes that we saw in game. We were able to kind of, also cool here is we're able to kind of get our sample of our texture from our virtual render target and kind of use that to help blend these rocks, or blend these like kind of procedural grass that we kind of generated in Houdini as well. And kind of all these assets we can kind of create as tools for our environment artists to kind of use to build, but also as part of larger architecture to kind of iteratively build these type of procedural approaches to terrain. I think that kind of rounds up our kind of our section on our demo. If we have any questions, I think on our either this demo, some of these techniques, or also just the course in general, I think now is a great time for this. We see a couple here in the chat. Let's see. I can take a couple here. And yes, it is spelled, I think, Dynasty, like Pete says. Well, the Course focus on Houdini, Unreal, game dev. What about VR mobile apps with Unity or scripting, rigging in Maya? So that's a good set of questions. It's gonna kind of focus on kind of uh sorry, it's gonna focus on kind of like what we call tech art rather than technical animation. Those are kind of two separate departments usually, or two separate camps of things. So it's kind of more focused on the technical art side of things. Although we allow some freedom. You can do something like that's even technically design oriented if you want to. In your kind of capstone project, you can do some technical animation there if you want to. We're kind of focusing this on kind of environment and effects and kind of Houdini, Unreal, Substance Suite, get in very real time game dev oriented. As far as like VR or mobile, we're not really covering that. We do cover like this stuff in the general sense. Like I'm a tech artist, I've worked on many VR and mobile projects, so I always think about performance in that context. Performance is a I always like to say performance is a way of life. It's not just like something you do at the very end of a project. It's like a set of procedures and practices. So like kind of we're approaching, we're always kind of approaching the way we're teaching things for you to think about, hey, if I'm going to be rendering this on mobile and maybe PC as well, I need to realize that there are certain constraints that I need to design around, that we're kind of teaching you when you're building anything here to think about those type of constraints. So in some ways, yes, but in like any direct form of example, no. Okay. Besides Dynasty, do you have any active TA group you'd recommend on Discord or anywhere kind of the same way for VFX, the RT VFX forums? I can give a couple. I don't know if I have the latitude to kind of share some of those in this chat, but I can give a couple. We talked about a couple examples. There's the techartist.org Slack. Those guys are always at GDC. They're really a lot of very smart people you can find there. There are just certain communities like Polycount. There are discords like TechArt Aid or Asher's Discord, or a lot of the DCC discords like the Unreal Slackers Discord or the ZBrush, Maya Substance, Houdini Discord. All of these are useful places to find community and to find artists that you can learn from and also help as a growing TA. What do you need for the one-on-one meeting when applying for the course? That might be a question for Yash a little bit more.
So you don't need a lot, just if you have a portfolio, bring along your portfolio. The meeting is essentially for us to get to know you before you sign up for the course, and just to make sure that you align with the course, and that we can help you, get the best result once you sign up for the course. So it's just more for that. So it's a more like get to know each other kind of a meeting. So don't stress out on that.
Very cool. Do we have any other questions?
I see one, which is, do you know what good demos for Python or scripting looks like for a TA, or what kind of work employers look for with Python or scripting? It seems highly in demand, but also nebulous with regards to what's desired, since Python scripts um, since Python scripts virtually add any functionality to software that use them. Is it
Yeah.
similar to my earlier question? So yeah.
So there's like two domains to answer this question, two ways. So um, there is like a sub discipline. We don't cover this content super in depth just because I think it's a little bit more than what we could probably fit into a boot camp. But there, just like there might be procedural or environment tech artists, is a type of tech artist called a pipeline tech artist. Sometimes called a pipeline TD, and their job is kind of the pipeline. They're not concerned with like rendering or concerned with uh maybe to a certain degree they're concerned with tools, but they're really concerned with like getting things from point A to point B and building tools for that purpose. Batch automations, batch baking, but a lot of times it is getting one tool to maybe talk to another tool automatically. And a lot of times those APIs are all done in Python. And you can, it is true, they kind of point out here in their question that, what do we, if I'm trying to learn Python, or like, let's say I'm going from a more programming background, let's say, if you're more programming background, maybe you have some background in something like JavaScript, TypeScript, or something in that environment, and maybe you're familiar with Python, like, well, but Python, like, do I learn Python for Maya API? Do I learn Python for Houdini or whatever? Like, it's kind of like two domains. So in some cases, when I'm searching for someone, I might be looking for somebody who's like, oh, that's my Houdini specialist. That's my Maya specialist. And that Maya specialist, they're probably going to know Python in that context, but they might also know something like Mail. If I'm looking for my MaxScript guy, okay, he's probably also going to go Python in that level. Generally, it helps you. Let's say that's where you want to specialize something like Python. Um, it benefits you, one, to kind of know enough of it off the ground just to make small little applications, small little command line applications where you can just make certain, like, take a set of images and like maybe make one flipbook from it, or like do some sort of batch process of deleting or moving things like that type of really simple like just bespoke little executables. Because those, a bunch of those, like, really a pipeline really, it starts to be built to have a bunch of tiny little things like that. Like, I click this button here, and that tells that exports these things, and it runs this script that grabs these files and moves them somewhere else or something like that. On top of that, it is helpful to know a little bit about how Python is, or some tool like that is kind of used in different things. And that's also, I would say, if you're like a shader, let's say shaders are your thing, like, oh, materials, that's my focus. I would say the same kind of thing applies to them as well, where like there is, like, sometimes we have, oh, that's my Python guy, but you should know how that is kind of implemented across the board of common tools. So like you should know HLSLS, but also have some comfortability with GLSLS, and have seen how you might do shader approaches in something like COPS and Houdini, in something like a pixel processor in Substance Designer, but as well as in like the material net editor in Unreal or Niagara. You can kind of use those same skills like flexibly across domains, and you kind of want to be able to do the same thing with something like Python. There's a lot of really great courses. I would actually say Houdini is a really great place to kind of learn Python and focus Python kind of as an IDE, because one, you get a lot of control, but also because one really cool thing about Python is like all the cool machine learning models in Python 3 that you have access to, like with TensorFlow and PyTorch. And Houdini kind of sets you up, especially using the TOPS context, to kind of work and play with those in a way that's really, really interesting and modular. It's almost kind of like, I don't know if people have ever used Comfy UI. Imagine if Comfy UI had like the industry leading effects and geometry procedural suite kind of hooked up into it. And that's kind of what you get a little bit with TOPS and using some of these Python modules. Okay. See if there's another good question. Will we have access to this recording? I do believe it's going to be emailed out to you guys, actually. Yeah. Do you see another good one, Yash?
No. I see Liz asking, will we have access to the recording? Yeah, we'll be sharing the replay for this in case you were not able to catch everything. And also, folks, I'm just posting a link in the chat. So if you want to check out the week by week syllabus for this course, you can check it out on that link. Are there any more questions from you guys? If not, I think this would be
Phenomenal.
yeah, I think this would be a good spot to wrap it up then. Okay. I guess we'll wrap it up now. So thanks for joining us, guys. I hope this was super useful for y'all, and you guys had a good time. And we hope to see you at the course.
Thank you, guys. I hope you found this interesting and useful.
Thanks, guys. Thanks for joining us.